Okay. Okay, so this is the problem statement. Okay, so it's just read. Okay, or maybe I'll let read. Let's say it talks about, okay, order to maximize profit for the quarter. You're looking to maximize profit for the quarter. Okay, so this is a computer making company. Okay, they make either notebook, they make the notebook and desktop. Okay, how to solve in Excel also, we'll take it out. Okay, so first we'll do that in the Excel. This, I think I got the wrong one, not this one. I don't have a license for this. So there's a company called Indigo, and they make laptops and desktops. Okay. Okay. So let's say we call, so let's say this is a notebook, and this is desktop. Okay. So question is, how many laptops and desktops should they make? Okay, right? So objective is, okay, okay, how many? So let's say we call it as X and Y. Okay. So the idea is to maximize profit. Okay, maximize profit. So it says that notebook generates 750 rupees, okay, profit, and desktop produces 1000 profit. Okay, so the profit would be what? Okay, so profit would be 750 into X plus 1000 into Y, correct? This is the profit. So once we know, yes, see, each notebook is giving 750 rupees profit, and desktop is giving 1000 rupees profit, right? So if we know X and Y, we can easily calculate how much profit they're going to make. Okay. So the answer, if you have this much, answer could be anything, right? You can make 1 lakh, 1 crore notebook, 1 crore desktop. But life is not like that, okay? Life always will have constraint. No, you cannot do everything that you want. There is always constraint. What are those constraints here? So first constraint says each computer requires a processing chip. Okay. So constraint 1 is about processing chip. So what is the constraint here? Constraint says each computer requires a processing chip, both. Okay. So if it is, 1 time X and 1 time Y, okay, both requires one piece, and totally you have 10,000 chips, right? So you have 10,000, correct? Now the total chip that you use can be less than or equal to, right? So that means X plus Y, okay, it means X plus Y has to be less than equal to 10,000. Yes or no? Okay, you have 10,000 chips. Each computer, a notebook or desktop needs 1 chip each. So, you can make, based on this condition, you cannot make more than 10,000, right? Now, based on this, it is profitable to make only desktop, because desktop gives you higher profit, 1,000, right? So if maximum you can make is 10,000, then why to make, notebook? Just make desktops. Okay. Now let's look at other constraint. Second constraint says each computer needs memory. So they have a 17 MB chipset, very old problem. So memory comes with 16 MB chipset. Okay. So notebook needs 16 MB, but desktop needs 32 MB. So we need to have 2 times. Okay. So here your desktop needs 2 chipset, 2 memories. Okay.
Notebook needs 1.
Notebook needs 1. Okay. And this total is again less than equal to, okay, 15,000. So you have 15,000 in your stock.
Yeah.
Okay. It means what? It means
x plus 2y less than or equal to 15,000.
yes, x plus 2y less than equal to 15,000. Okay, now this is different than NumPy because NumPy was equal to. Okay.
Yeah.
So when you have equal to, you can use NumPy, but when you have less than equal to, greater than equal to, then you have to use SciPy.
SciPy.
Okay. Great. So this is your memory. Next, third constraint. Okay, it says due to assembly time. Okay, assembly time is where you manufacture. You tighten the things, right? So here it says that it takes 4 minutes. Okay, so assembly time is 4 minutes versus 3 minutes.
3 minutes.
Right? So, and there are 4 minutes is for what? Notebook, right?
Yeah.
So we're talking about minutes. So, assembly time, 4 minutes is for notebook, 3 minutes for desktop, and
25,000.
25,000 is the maximum assembly time minute that you have.
Yes.
So here, your
4x plus 3y
4x plus 3y
less than or equal to 25,000.
Okay, so
Yes.
these are your numbers, right?
Yeah.
Now, question is how many desktop and desktop and laptop they should make to make maximum profit. Okay, so so what we'll do is, okay, let's assume, okay, let's assume this is assumption. Let's assume the total notebook that you make is 1 and desktop you make is 1. Okay, this is our assumption. Let's say we make only 1 desktop and 1 notebook. Okay, so how much processing are you using processing chip?
1 each.
So we'll put it here and profit, we'll put it here. So it is 1 into
750.
1 plus 1
into 1,000.
1 into 1.
Yeah.
So you need 2 processing chip.
Yes.
Right? How many memory you need? 1 into 1 plus
1 into
1 into
2.
2. Okay, assembly time
4 into 1. Yeah, 1 into 4.
4 plus 1
into 3.
into 3. Okay, makes sense, right? So if you decide to make only 1, this is what you get, right? And of course, 237 is less than 10,000, 15,000, 25,000. And how much profit you will get? Profit is going to be
1750.
right. 1750 into 1. In Excel, it is important to write the formula. Okay?
Yeah. Yes, sir.
Into 1. So you get. So your profit is 1750. Okay. But of course, you know that you can make it more than 1, right? If I make it 2, right? So this is also holding true. Desktop, maybe I'll make it 100. Okay. So this all holds true. So you have to keep on playing with it to see what is the maximum value. Okay. Manually, it is impossible to do that. So what we do here, this is the profit. Okay. This is what we want to maximize, isn't it? So you go to data, and here you will have, okay, what if analysis. Okay, I just give me a second. I have to do something. So what we have done so far, we have to maximize this value, isn't it? By changing these two. Yeah. So we need to find the right
number of notebooks and desktops.
Correct. So here, okay, you have you have data analysis. Okay, you need solver. Okay, it's called solver. Okay, if you don't find it here, okay, by default it may not be added on your Excel. Okay, so you need to go to add-ins. Okay, go to Excel options. Okay, you have add-ins here, right? Click on add-ins, and then Excel add-ins. Click on go. You see solver add-in. We need solver. Okay, so this we need for optimization. You say okay. So now you will see your solver. Okay, so click on solver. Here you see set target cell. Okay, what is your target cell? This is the target cell. This is what we want. Okay, now this is what you want. You want to maximize or minimize or set it equal to. Three options you have. You want exact, let's say, 500,000, okay, or 5 lakh as profit. You can set value of. But in our case, we want to maximize. Great. So maximize. Okay. Now, by changing cells, which cells you want to change? These two cells. These are the two cells that we want to change. Constraints. So the three constraints we have. All three constraints have to put it here at the bottom. Okay. So you want to try meanwhile? Okay, just give me 5 minutes. I'll be back. Want to try? Try building this in your Excel and use solver to solve it. Okay.
Okay.
So the way I have written here, same way we have to write. Okay.
Okay.
I write the formula, and then we will solve it. Okay, everybody till here? Have you reached here, Pujita?
Sir, I'm just preparing the data in the sheet. Can you just repeat the last few minutes, sir?
Repeat. No?
Yeah.
Have you done this profit? Have you calculated this?
No, not yet, sir. I'm just entering the data. Yeah, and I'm not finding, I can find data tools, outline and all, but analysis part is not visible on my sheet, sir. Not analysis, solver add-in. Solver. You have to go to in Excel. The analysis only you have the solver, no, sir. No, it's not an analysis. You have to go to this here, Excel options. Okay. Add-ins. Okay. Then Excel add-ins. Then all these things are available. So solver add-in. You have to add the solver add-in. Okay. So D16, yes, I want to maximize by changing. So by changing these two cells, so I'm selecting these two cells. Look here. Yes, so we're selecting these two cells. Done. And now I'm saying add constraint. Constraint, cell reference. So this is the left side reference, less than equal to, and constraint is 10,000. So D12 has to be less than this. Now add one more constraint. Okay. Add one more constraint. So D13 should be less than this. Add one more constraint. This should be less than this. Now you say okay. Okay, and say solve. Okay, so it has solved. So it's saying to make 1,000 notebook and 7,000 desktop. This is what solver has given the answer. Okay, so you have something called as optimize. These are called optimization problem. Okay, so SciPy dot optimize. Okay, and we will use. Okay, so you see by default. Okay, so finally cab is booked. No, we cancel it. Okay, so what happens? Okay,
you have two types of problem, right? One is called optimization. One is maximization problem, other is minimization problem, right? So either you have to minimize the value or maximize the value. So what we have here is a maximization problem.
Yeah.
Right? We have to maximize the profit.
Yes, sir.
But the logic which is written, the function which we have, okay, is minimization problem. Okay, so it's for minimization. Now, how do I minimize the problem? How can I convert maximization problem as to minimize?
We can consider the constraints. They have to be anyway minimized, sir. Time.
What am I saying? What are you saying? So it is to maximize. Okay, our objective is to maximize. How do I convert a maximization problem to minimization problem? So see, you want these values to be maximum, right?
Yeah.
Now, if I have to say minimize, now I have to minimize this to the maximum possible, right? So if you multiply this minus into -1, okay, it becomes a minimization problem.
Yeah.
See, now for example, you have 10, 20, 30, which is the maximum value?
30.
30. Now if I multiply with -1.
-10 is the maximum.
-30 is the minimum. You want the minimum.
Yes, -30 minimum.
So if you multiply with -1, your maximization problem will become minimization problem. Okay. Our objective is to maximize this value. To maximize this, if you multiply, okay, we have minimization. Minimize is the algorithm that we have. So if you minus with -1, if you multiply with -1, it becomes minimization. So what we'll do later is, when we write our objective function here, okay, when we write our objective function, I'm going to say profit equal to, what is profit? 750 into X, 750 into Y, correct? So to begin with, right, we took some random number, right? So let's say I put X equal to 1 and Y equal to 1. So your profit is now 750, okay, 750 into X plus
1000 into Y.
1000 into Y, right? But this is to maximize. To minimize, I'm going to say minus 750 into X minus 1000 into Y. Yes?
Yes, sir.
Okay. So converting maximize to minimize problem. Done. This is the only change you have to make. Okay. So profit per this thing is 750. Okay. And number of units is X. We need to find X and Y. Okay. Great. Now we have to create what is called as objective function. Okay. So objective function equal to, okay, it's a list. Okay, so list, I'm going to say profit desktop, okay, equal to 750. In fact, we should write this before, right? Right. And see, other we can do this one also, and we can do profit desktop, comma profit notebook equal to 750, comma 1000. So here you can say profit desktop and profit. Okay. So objective function is profit notebook, profit desktop, right? And here we are doing it in minus sign, right? We're doing minus sign. Okay. So this is our profit. Okay, so objective function, which is profit, and profit will be total of this. Okay, now this is where we are converting maximize to minimize. Okay, so our objective function is ready. The next thing is we have to find constraints. So we have another function here called linear constraint, using which we need to pass the constraint. Okay, and okay, we also have to, since this is a linear optimization problem, right? We'll also import linear algebra, linear programming. Okay, so our objective function is ready. Yes.
1 second, sir. Desktop profit is 1000, no, sir.
Okay, sorry, the reverse, right?
Yes, sir.
Okay, yes. Now we will write our constraint. Objective function is ready. So we'll have left-hand side constraint. Left-hand side constraint is your list, right? Okay, so left-hand side constraint has 3 constraints, right? It's a matrix, isn't it? So what are the values? 1, 1, 1, 2, 4, 3.
Processing chip.
1,
Yeah.
1, 2,
4, 3.
4, 3. 1, 1, 1, 1, 2, right? X, we have taken notebook, right? So, no, X is notebook, right? So we have to maintain
reverse.
Okay.
Yeah.
Okay, so first notebook, then desktop, 4, 3. Okay, this is our left-hand side constraint. Now, what is our right-hand side constraint? Right-hand side constraint equal to, okay, so here you have 10,000, 15,000, 25,000.
Yes.
10,000, 15,000, 25,000. Done. Okay. So what are the values that your X and Y can take? Okay. The values X and Y can take
Integer
is 0 to infinity.
Yeah.
It cannot take negative.
Yes.
Right? We call them as bounds. Okay. So for each of the value, we have to say what is the maximum. So let's say you had a constraint that you cannot manufacture more than 10,000 desktop. Let's say if that's a constraint. Okay. So it will be 0, 10,000, right? So here we talk about, okay, the bounds. Bounds is the maximum value that these values can take. Okay. So
Limits simply.
Given as as a list of tuples. So this is okay. This is where I'll give the bound for first, which is desktop. No, notebook, right? And then we'll give for desktop. So for notebook, it is 0 to infinity. So how to write infinity? We have a function called float. In float, if you pass INF, it'll give us infinity, okay, in quotation. So this is like declaring infinity, 0 to infinity it can take. Or if you don't want to give infinity, you can give very big number. See, we know that values that it will take is definitely not more than 10,000, isn't it? Because even if you decide to make all notebooks, 10,000 only you can make. If you decide to make all desktop, 10,000 you can make. So you can give infinity, or you simply give 0 to 10,000. Okay, more less number you give, more faster will be your output. Okay, so just showing you that you can give infinity or you can give 10,000, because we know it cannot go beyond 10,000. It has to be less than 10,000. Okay, great. So this is the the bound that we created. Now we have to call our function. Okay, our linear program. So I'm going to say optimize solution equal to linear program. Okay, and we need to pass here objective, bounds, and which method you want to use. Okay, so we are using simplex method. Okay, it's called simplex method. So first thing first, the objective. C is your objective. So here I'm going to pass obj function. Okay, great. Now left hand side constraint is called a ub bound, a bound. So this is our left hand side constraint. Similarly, you have b. Okay, see the b is in small. Okay, because right hand side will have only single values, right? It can't, so that's why it's saying b small, but b ub is for right hand side constraint. So it is right hand side constraint. Oops. Clicking wrong button. Okay, so we have got right hand side constraint. Now we have to give the bounds. Okay, so bounds, bounds is our bounds. Okay, so these are the boundaries within which the values can exist. So objective function, left hand side constraint, right hand side constraint, bounds. Okay, and the method that we want to use. Method, it's called simplex, revised simplex actually. Okay, it's called revised simplex. So revised simplex. Okay, now if you want, you can see this in the documentation. So I'm going to say SciPy dot optimize dot linear prog, right? And we'll say documentation. SciPy dot optimize dot linear optimization. This is the official manual. Okay, we go to this and we'll see. So we have simplex, revise simplex. Okay. See objective function a bound, left side constraint, right side constraint. Okay, if there's equality, if we have equal, so this is a upper bound is for giving upper bound. Okay, not more than kind of. If you have equality sign, something should be equal to, cannot be less than or more than, then you say a underscore eq, right? In our case, we do not have any equality thing, right? Bounds, methods. Okay, so methods, there are multiple methods. Okay, so we'll look at the methods here. So here it has, okay, high IMPS, revised simplex is the legacy. Simplex is the legacy. Okay, so we can use revised simplex. Okay, this is the old, legacy means old way. Okay, so we'll say revised simplex, there is no underscore. Okay, so now our solution is ready. Okay, this will give us true if you got an answer. Okay, it will give us false if you do not get an answer. So if I say if optSol dot success, okay, that means you got an answer. Otherwise, you have not got an answer. Print solution is opt solution. So let's run this and see. Okay, see 1000 and 7000. Is this the same value we got here? 1000 and 7000. See, so same answer is given to us by SciPy also. These are the values of opt solution.
Okay.
So function is minus because we said minimization, right? So minus. So total profit, you multiply back again with -1. So this is a total profit. Okay, and this is our solution, 1,000 and 7,000.
What is that NIT2 and all that, sir? Slack.
Variables. Okay, number of variables is to slack. Okay, so again, if you get into Simplex, okay, you will understand this. Simplex, what they do is, okay, now when I say, if I say 3x plus 4y, it is less than equal to 5, let's say, right? So this is the equal to 3x plus 4y less than equal to 5. But when you say less than, right, then it's very difficult to solve less than problem, or when you say greater than problem, difficult to solve. Okay, because less than means what? Everything is possible. If it is equal to, then it is easy to solve.
Yeah.
Less than is difficult. So what they do is, and that's a simplex. Okay, we'll not get into details of that.
Okay.
But you know what it does. It does is, when you say equal to, so we add some value. Okay, we add some value to it, so that, okay. Now see, this is less than 5. So if I add something here, okay, let's say I add a, then it will become equal to, isn't it?
Okay.
Okay.
Yeah.
And let's say if the reverse is there, let's say 2x plus 7y is greater than equal to, let's say, 100. That means if I minus something here, minus b, it becomes 100, isn't it? So when you add something, it's called slack variable, because it is slacking. You are adding it to make it equal to. Okay, so now they are equal. It's called slack variable. And here, when you minus something, it's called surplus variable. So you'll see slack and surplus. So when it is less than equal to, it is slack. Generally, we add. So adding is, this is slacking. It's behind. Okay, it's going back. So you are adding it to be equal to 5. So the value of a, b, that's what it's saying. Okay, slack variable is, so here if you see, because we have 3 constraints, isn't it? 3 less than equal to, right?
Yeah.
These are the constraints. Okay, so it's saying if you add here 2000, it becomes equal to. Here, you don't have to add anything, 0, right? 2 to 0. Okay, here, okay, what it means is, okay, what it means is, the solution that we got, right? The solution that we got,
yeah,
1000 and 2000, 1000 and 7000, right?
Yep.
So if you substitute 1000 and 2000 here, these two will be equal to, exact equal to, there's nothing to add, right? If you see this, 1000 plus 2 into 7000, 15,000,
yeah,
right? So plus 0 is 15,000.
Okay.
Here 4 into 1000, 4,000 plus 21,000. 4 into 21, 25,000. Okay.
Yes.
Exact. This is solved. Now, if you go here, 1000 plus 7,000 is 8,000.
Okay.
Correct. So 2,000. So you saved 2,000 memory chips. Is it memory chips? No, it is processing chip.
Yeah.
So your time and is totally, 1 second. Sorry, my bad. Okay, so so you're saying that your memory chipset and assembly line, you will not be left with any value. It's totally consumed. Okay, but processing chip, you are left with 2,000. That's what it's saying slack. Okay, so it is it is less than this point 2,000. Okay, so that's your slack variables.
Okay, sir. Sir, line number 15. That is the syntax of finding the simplex problem, sir.
For doing linear programming.
Okay.
It's called linear programming. So you have linear programming, non-linear programming. Linear programming is used when the power of x is 1. In this case, you see it is all x. Okay, x plus y. Okay, we call it as
power is 1 for all the variables.
Correct. Power is 1, so it's a linear problem.
Okay. Yes,
if you had x squared, x cube, x squared, y, okay, then we have to use non-linear programming. Okay, that is okay. We'll probably can discuss later. Okay, we use non-linear programming for that. So linear programming is when your power is 1. When power is not, see, linear means what? Your line will be a straight line. So when your power is not 1, power is 1, not more than 1, it will be straight line. If power is square, it becomes quadratic, it becomes a curve.
Yeah.
Quadratic, so on. Then we have to use non-linear programming.
Okay.
Non-linear programming, we have different methods. We have exhaustive search and other different types of problems. Okay.
Okay, sir.
If you want to, get into details of mathematics, which I would recommend, okay, if you have time, you can join this SWAYAM course. Okay, SWAYAM course are done by professors of IITs. They have a lot of good of mathematics. Okay, so you can do that. Okay, you can talk about essential mathematics. You can talk about optimization techniques.
Yeah, optimization actually we covered in our BTech 4th year.
Yeah. We covered in BTech, and this is the exact thing. Okay, in BTech you will have non-linear. You'll have linear, simplex problem. Okay, but if you want to get into non-linear, okay, that's what I'm talking about. Okay, so
okay, sir.
Our course, what you're doing, we're doing BTech thing only, what we know, okay, at level. But the concept you should know. Okay.
Yeah.
Okay. Now here, this is not part of your machine learning. This is part of your what you call deterministic mathematics. Okay. Whatever we have done so far is determined. We'll get only one answer. Okay. If these are the constraint, then this is the answer. Okay. Answer cannot be anything else. Okay. So in optimization, you'll have minimization, maximization, traveling salesman problem, CPM transportation. Okay, so those are your simplex applications.
Yes.
Okay, so with that we finish our SciPy. Okay, SciPy, it's an advanced level of NumPy, and this is good example to solve.